Okay, good morning. So we continue the lesson, but today we have a new lesson. It is equation systems. So we know a lot about equations by now, but we have only one equation and one unknown. Yes. So for example, we had a very simple equation from Math 1C, something like 2x plus 5 is equal to 9. Here we have one equation and one unknown. Yes, one equality and one unknown. But of course, we learned a little bit more about this. We were able to solve more diversity of equations in one unknown. For example, we learned also how to solve this equation. For example, yes, this is quadratic equation. We also learned how to solve root equations, I don't know, fraction equations, a lot of equations, but all of them are one equations and one unknown. We were just looking for one unknown, yes? But sometimes, for example, here, there is only one solution, but you learn that in quadratic equation, it might happen that the same unknown has more than one possibility, okay? But now today we want to talk about equation systems. It means that you have more number of equations and more number of unknowns. Okay, and of course we don't want to go. I want to keep the level more or less the same as the book, but I just want you to know that if I increase the number of unknowns, in principle, I will be in trouble. For example, if I start with simple equation x plus 1 equals to 3, this is one equation and one unknown. So if I want you to find that one unknown, you can immediately do that. But let us say instead of 1, let me write y. X plus y equals to 3. Again, what do I mean? This is one equation because you have one equality, but you have two unknowns. So it means that I am looking for all possible values x and y for each x plus y equals to 3. Okay, so how many unknowns you have? You have two unknowns, but you have one equation. So this I want you to have. This is a general idea. If I have two unknowns, x and y, if they are not related, how many possibilities are there for x? How many possibilities are there for y? If I just say x is one variable, y is also another variable. So you have infinitely many options for this one, infinitely many options for this one. X can choose any value, regardless of the value of x, y can also choose infinitely many values. So x can be any number, y can be any number. But when I put some relation between them, this is called a constraint, yes? I'm constraining it, it's a constraint. I put a constraint on x and y, okay? So before putting a constraint, this is sometimes good terminology to learn. We say we have 2 degrees of freedom. What do I mean? It means that x is free to choose whatever it likes. Y is also free, regardless of the value of x, to choose whatever it likes. Okay? So these are independent of one another. They don't have any relation. Okay? But now I have 2 degrees of freedom, one for x, one for y. But if I write one equation between them, one relation between them, it means that I am putting a constraint on them. I have two unknowns. I am putting one constraint on them. So you need to think in that way. This constraint removes 1 degree of freedom. Okay? But how many degrees of freedom will be left? You see, when I have two variables without any relations, I have 2 degrees of freedom. What do I mean by that? It means that I have two entities. They are free completely. This can choose whatever it likes, independent of what this x chose. Y can also choose infinitely many, okay, independent of that. So I have 2 degrees of freedom, one freedom for x, one freedom for y. But as soon as I write a relation for example, here, is it possible that x takes 3 and y takes 9? Is it possible in this case? In this case, not this one, in this case. Yes. Yes. Is it possible that this takes a square root of 3 and then this takes a square root of minus a square root of 5 over 2? Yes. Because now, because here, without any relation between these two variables, I have two complete free variables. This can attain any variable that it likes. This can also attain any number that it likes. But when I put a constraint here, it means that I have to be more careful. I do not have 2 degrees of freedom anymore. How many degrees of freedom I have? I have 1. Because I had 2 degrees of freedom. By putting one constraint of them, in principle, I am taking off 1 degree of freedom. For example, in this case, as soon as I choose a value for x, for example, if I choose 2, then y has to obey this choice. Y cannot be anything it likes. As soon as x is chosen, y is determined by this constraint automatically. So what is y in this case? Y in this case is 1. If I insist to choose x to be 2, there is only one possible value for y, and that is 1. Okay? But then I can freely choose x whatever I like. For example, I can choose x to be 3. As soon as I choose x to be 3, y has to obey. There is no degree of freedom left for y. Yeah, so what is y in this case? 0. For example, if I choose x to be minus 9, y has to obey. Y does not have freedom anymore to choose whatever it likes. So what is y in this case? 12. Yes? So you see, as soon as I assign a number to x, which is free, I can assign any number that I like to x. It means x is free, 1 degree of freedom. But y loses its freedom. Y has to obey the value of x because of the constraint that we have here. Or, of course, can y be assumed to be free? Yes, I can choose whatever I like for y, then in that case, x has to obey. The point is that when I have one constraint and 2 degrees of freedom, putting one constraint will remove 1 degree of freedom, 1 more degree of freedom will be left for me. Okay? So now let us assume that I not only put one constraint here, x plus y is equal to 3, I would put another constraint here, for example, x minus y equals to 7. So let us analyze the problem again from that perspective. Let us start from scratch again. Before putting any relation between x and y, how many degrees of freedom I have? 2. What does it mean? It means that x is free to choose whatever it likes. Y is also free to choose whatever it likes, independent of what is the choice for x. Yes, is that clear? I have 2 degrees of freedom. When I put this constraint on it and nothing else, this is one constraint. Initially I had 2 degrees of freedom. By putting one constraint, I am removing 1 degree of freedom. How many 1 is left? 1 more is left. Yes? What does it mean 1 degree of freedom is left? It means that you are allowed to choose any value for x you like, but y cannot choose any value it likes. It has to obey the value of x. So even though x is free, but y is not free. So I have lost 1 degree of freedom. Now let us go to this situation. How many constraints I am putting on x and y? 2. This is the terminology. This curly bracket is the standard. So if you want to write 2 degrees of, if you want to write 2 constraints, you have to use curly brackets. Don't put parentheses, don't put the square brackets. You have to put curly brackets. Curly brackets in this case means and. Okay? So this means that I am putting 2 constraints. One constraint is x plus y equals to 3 and x minus y equals to 7. So how many degrees of freedom I had in the beginning? 2. How many constraints I imposed? 2. So how many degrees of freedom are left? Nothing. When there is no degrees of freedom left, it means that x cannot choose anything it likes, y it cannot choose anything it likes. X has to be a fixed value, y has to be a fixed value, no degrees of freedom. X has to be the same, exactly one number, y has to be exactly one number. This is the general idea in the back of your head when you have systems of equations and unknowns. I'm not saying that this is a completely generic rule, but this is the way that you have to think about it. Okay? So now we want to see what is x and what is y. So you should expect that you have one answer for x, one answer for y, because 2 degrees of freedom, both of them are gone with 2 constraints. No freedom is left for x, no freedom is left for y. It means x should be exactly one number, y has to be exactly one number. No degrees of freedom. They are not free to choose some values. This is the idea. Of course, this is the generic idea. This is good to have in mind. Okay, now we want to solve this. What do I mean by solving a system? This is called a system of 2 equations in how many unknowns? 2 unknowns. I can immediately assume that I can have a system of 3 equations, for example. I don't know. So this is also equation of what? This is called an equation consisting, a system consisting of 3 equations in how many unknowns? 3 unknowns, yes? So let us try to analyze that. Before even starting looking at the equation, I have x variable, y, and z variables. Without any relation between them, how many degrees of freedom I have? Anything. So don't look here. I have x, y, and z completely independent. So how many degrees of freedom I have? 3. But now, when I just write this one, not these ones, how many degrees of freedom I have? 2. Yes, because I had 3. One constraint gives me 2. So what does it mean? So let me just write this. X plus y plus z equals to 7. What does this mean? It means that you have 2 degrees of freedom. It means that you can choose any value for x. Let us say 0. You can choose any value for y. You have 2 degrees of freedom, but z has to obey. Z is not free anymore. Yes, is that clear? For example, if I choose x to be 0, y to be 2, what is the value for z? 5. You see, I have 2 degrees of freedom. I can play around with these numbers. I can choose whatever I like for x. I can choose whatever I like for y. It means that I have 2 variables that are free, 2 degrees of freedom. But then z has to obey. So as soon as I put one constraint between 3 variables, 1 degree of freedom is removed, 2 degrees of freedom are left. Now let me add another equation here. Another equation is, for example, x minus 2y plus z equals to 6. How many, and then if I stop just there, how many degrees of freedom do you think there will be? What?
2.
No, degrees of freedom. So I had 3 degrees of freedom. How many constraints you see? How many limitations you see? 2. So I had 3 degrees of freedom, 2 constraints, remove 2 degrees of freedom. How many degrees of freedom are left? 1. Yes? Okay. And then finally, if I have 3 constraints, how many degrees of freedom do you expect to be left? 0 degrees of freedom. It means that x and y and z have to be fixed. They have to be fixed numbers. So that's the general strategy behind it. Okay, but I don't want to start with this form. We want to start with this one, okay? Now you expect that you have 1 degree, a 0 degree of freedom. So it means that you should be able to find one value for x fixed and one value for y in general. I'm not saying that this is always true. But the point is that how to find the answers. There are 2 methods in the book. I will teach both of them. One method is called substitution. This is the most important one, okay? Because this substitution is a general idea of a solving system of equations in general, not only these simple ones. But for these kinds of equations, we also have another method, which is called the addition method. I will teach both of them today. This is very simple. But then, of course, we will increase the level of difficulty a little bit after we are familiar with this. I don't think that's a very big problem. I think even in Grund school, you learn how to solve systems like this so simply, yes? So let us try to first focus on substitution method. So I give you this equation, this system of two equations in two unknowns, and I want you to find the solution of this system. Okay, first of all, can you tell me what is the solution here now? For example, in this equation, you say x is equal to 2 is the solution. What does it mean? It means that x equals to 2 is the only number for x for which the left side becomes equal to the right side. That is the meaning of a solution. I don't know, if you use ABC formula here, then what you will get is that one solution is 1, and then you get another solution is minus 9 over 2, if I'm right. So when I ask you to solve this equation, you use ABC formula, you get these two numbers. What are the meaning of these two numbers? The meaning is that x equals to 1 and x equals to minus 9 over 2 are the only numbers for which the left-hand side becomes equal to the right-hand side. But what is the meaning of a solution to a system? A solution to this system means what is x and what is y, so that not only the first one works, but also the second one. So it is important. If I just give you this one, if I just give you x plus y equals to 3, you have a lot of answers. For example, this is one possibility. We call it one answer. This is the second possibility because you see the sum of them is 3. This is the second possibility. And then this is the third possibility. If I just write the first one, how many possibilities do you think I will have? Infinitely many, because I have 1 degree of freedom, and that 1 degree of freedom can choose as whatever it likes. Yes? But now when I ask you to solve this system, I mean to find all pairs. Find all pairs. Yes? All pairs x and y for which not only the first one is true, but also the second one is true. Yes? So that's the meaning of solving a system. Solving a system means just not guessing. You need to make sure that you are finding all possible pairs, not just one pair. Okay. Method of substitution I want to teach you. First of all, you choose one of these equations. In principle, it doesn't matter which one you choose, but I recommend you to choose the simpler one if one of them is simple. In this case, they are of the same level of difficulty, so it doesn't matter. So let me choose the first one. Okay? And what you do, you now need to choose one of the variables. So first step is to choose one of the equations. Choose the simpler one. In principle, it doesn't matter which one you choose. But choose the simpler one because the algebra becomes simpler. And then after you chose your equation, decide about choosing one of these variables. I also recommend you to choose the one which is smaller coefficient. But in this case, again, it doesn't matter because both of the coefficients are 1. And then, for example, let us say I decide to choose y. Assume that y is your unknown, and then make it the subject and write it in terms of x. So it means that isolate y. For isolating y, I have to remove this x to the other side. So it becomes 3 minus x. Yes? So that is called the method of substitution. The substitution part is not clear yet. What I did, I chose one equation, I chose one variable, made it the subject, and find it, isolate it. And then put this in the second equation. Substitute it, that's why we call it substitution method. Substitute it in the second equation. So what happens? I write x minus, be careful, it is not correct to write it like this, minus the whole y. So you have to write a pair of brackets around it. And that's equal to 7. This part is, this is why this carries the name of substitution. I substituted this for y in the second equation. And then what do you have? You have only one equation in one unknown. There are no two unknowns anymore. Okay? So then you start solving this. I multiply the minus sign in. You see this minus sign not only goes here, but also goes there, and that is 7. And I have x plus x is 2x, and minus 3, I move it to the other side, it becomes 10, and then divide by 2, it becomes 5. So this is the answer for y. Sorry, for x. X is equal to 5. And then it doesn't matter. You can carry this 5, put it here, find y, put it here, find y, or even put it here, find y. I prefer to put it here because this is ready for y. So then I put this back here. Y becomes 3 minus 5, which is minus 2. So y is minus 2. So what I have to write for the solution is this. X is 5 and y is what? Minus 2. If I ask you how many solutions I get, for how many solutions I got, how many? 1. That's good. Don't say 2. Because a solution is not x, is not y, is a pair of x and y, so that it works for all the equations. So x is one number, y is one number, and that is consistent with what I told you, yes? We had 2 degrees of freedom, we had 2 constraints, so no degrees of freedom are left. So that's exactly true, because x cannot choose whatever it likes. X is a fixed number 5, and y is a fixed number minus 2. So this is called a solution, or in this case, the solution, because there is no more than one solution. But I want you to know that this is one solution. And sometimes people write it as a pair, and this is the convention. When you write it as a pair, you have to write the x1 first, comma, the y1 second. So you can also write it like this, x and y. The pair of x and y is equal to the pair of 5 and minus 2. But that's one solution, yes?
If the amount of variables equals to the amount of constraints, is there only one solution?
No, this is the general idea. Okay, but for example, I can give you this equation. I don't know, 12. Okay, so how many variables I have? 2 variables. How many constraints I have? 2 constraints. So in principle, that is still true. There is no degree of freedom left. But it doesn't mean exactly. Degree of freedom means that one variable can choose whatever it likes. So it is also true, because for example, one solution is x equals to 3. I didn't tell you how to solve it, I'm just guessing. Y is equal to 4, do you agree? Because x3 and y4 not only satisfies this 3 to power 2, 9, 16, 9 plus 16 is 24. 25, but also 3 times 4 is 12. So this pair is a real solution to this system because it satisfies both of them. But can you immediately see that there is another pair? Yes? Minus ones. Yes? Because if I choose minus 1, 3, and y minus 4, that also works. Yes? Because if I raise this to power 2, it becomes what? Positive 9, positive 16, it's still 25. And if I multiply them, it becomes 12. So how many solutions I have got so far? 2. Don't say 4. 2 solutions. One pair, another pair. 2 pairs. Okay, is there any other solution you can guess? With the same numbers. The reason that I am asking you, do you agree that I can choose x to be 4, y to be 3?
Yes.
But this pair is not the original pair. In the original pair, x is 3, y is 4, but in this one, x is 4, y is 3. So this, you should consider this one as well. Yes? So is there any other pair?
Yes.
What is that?
Minus.
Minus 4 and minus 3. Yes? So how many solutions you see so far? 4. But still, this is not solving. Because you might say, Babak, how do you know that there are no other pairs? And I agree with you, still I don't know. But I will talk about these kinds of systems. For some strange reason, the book doesn't talk about these things, but they are not very hard. Okay, we can solve some of them, at least graphically. Yes?
In the exam, do you expect us to write all?
Yes, yes, if I give you this in the exam to solve it, of course, this is not the correct way of solving it. I will teach you how to solve them. But that point is that I want you to see that here you might say that, okay, still I have degrees of freedom, but this is not degree of freedom, you know. Freedom means that you are allowed to do whatever you like to do. But here, x has to take either 3 or minus 3 or 4 or minus 3. So x is not free at all. So x is free to choose among 4 numbers, but it is not that freedom. Yes, that's what I'm saying. So that's why I'm saying that even though you have 2 constraints, 2 unknowns, you still have some small freedom left. Yes, but we can say we have a finite number of freedoms. Okay. So we will come back to this, but that's also good that you ask this question. So I want you to know that for the time being, I have written 4 solutions for this system, but still I cannot claim I solved the system. Why? Because there might be still other pairs that I cannot guess. So that is not a solution, even though you see I found four of them. So is that clear? So if I want to review, for the time being, don't concentrate on these harder questions. We will come back to them. We want to solve these kinds of systems. The systems of this type. These are called linear systems. Okay, what do I mean by linear system? I mean a system of this form. I mean, for example, ax plus by equals to c, and then, for example, a prime x plus b prime c y is equal to c prime. Yes, a, b, c, a prime, b prime, c prime are given numbers. You want to look for x and y. Why they are called linear? Can you guess why this is called a linear system? Yes?
Is it because it's a straight line?
Yes. So one reason is that is a straight. If you draw the graph of this, it becomes a straight line. If you draw the graph of this, it becomes a straight line. So these kind of systems are called linear systems. Another reason is that the degree of x and y is at most 1. Yes? So it means that that's a linear. It's not a quadratic one.
Well,
yes.
What's that? Near.
Prime means so if this means another letter, instead of writing E and F, I wrote A prime, because A prime means similar to A. It plays the same role as A. But if you don't like prime, putting prime, you can use different letters. You can use Greek letters or whatever. But this is very common in mathematics. So if 2 variables are playing the same role, one of them is denoted by prime or something like that. Okay. Or if you don't like it, you can put index for them. So you can write A1, B1, C1, A2, B2, C2. Something like that. Okay. Okay, so if I want to review, for the time being, we want only concentrate on linear systems. For linear systems, we have 2 methods to solve them, substitution and addition. Substitution also works for nonlinear equations, as we will see. So that's why I want you to learn that substitution method is completely generic for any kinds of systems. The first strategy comes to mind is the substitution. Okay, I haven't talked about addition method yet. Let me just review what I told you about substitution. So if I give you a system, a linear system, and you decide to solve using substitution method, what do? You go and choose one of the equations. Of course, preferably, it is better to choose the simpler one. When you chose the simpler one, you choose a variable there and make it a subject, isolate it, and you find it in terms of the other variable. And then you go to the equation that you haven't used. This equation was used here. You found y, you go back to the other equation, substitute what you got for y, and then solve the equation and find one variable. When you have this number, put it back here, there, or even better here, and find your y. And that's the end of the story. Is that clear? Let me immediately tell you what is addition method. Addition method for these systems of linear equations sometimes is superior because it makes the algebra and arithmetic simpler. For example, if I want to solve this equation by addition method, so let me write it here again and do it. So the equation is this. The system is this. X plus y is equal to 3, x minus y is equal to 7. You know, the goal is to get rid of one variable. Okay, so what we do, we want to add them here in a way that I can get rid of one of the variables. Yes? So here it is extremely simple to see that if I just add them, the goal is achieved. Yes? Because if I add this to this, what will happen? X and x becomes 2x. Y and minus y are gone. And then 3 plus 7 is 10. And what is x? 5. So it was much simpler here. So that's why I want to teach you both methods. Okay, in principle, one of them is enough. But when you found x equals to 5, you have to take this 5 with you, either to put it in the first equation or in the second equation. It doesn't matter which one. Both of them will give the same answer to you. For example, let me put it here. So then it means 5 plus y equals to 3. So y becomes minus 2. And then what you have to write? You have to write x is 5, y is minus 2, as we did before. So that's the addition method. Yes? But of course, the addition method, so this is an exaggeration. In both cases, this is the simplest system possible. Now, I want to give you more examples and then try to solve the system together. Are you ready?
Yes.
Okay. And for the first few examples, I will solve in both ways, that you can learn both of them. So the system that I want to solve here is, for example, 2x, so let me write it like this, x plus 3y this, and the other one, let me write so let me see. Okay. So let us solve this system. So let me write method 1, substitution method. Okay. So do you remember what I told you about substitution? You have to decide about one of the equations in the system. I told you, in principle, it doesn't matter which you choose, but from practical point of view, it matters. Which one do you prefer to choose? The first one or the second one? First one is simpler in form, so I will choose the first one. So I will start writing x plus 3y equals to minus y. So I made my mind to choose the first one. Now that I see the first one, I have to choose my mind about which variable you want to isolate. Again, in principle, it doesn't matter. But which one do you prefer to isolate? X is better. Because if I insist to isolate y, I have to move x to the other side, but I also have to divide by 3. So I have to do two things. But if I decide to isolate x, I just move 3y to the other side, I am done. So that's why I'm saying x is better. So what I do, I would write x equals to, I move this to the other side. Minus 1 is already there. I move this to the other side, it becomes that. Okay? The first step, decide about which equation you want to work with. The second step, decide which variable you want to isolate. Isolate it. What is the next step? go and use the other equation which hasn't been used yet. So here. And then instead of this x, you substitute this. This is called substitution method. So this becomes 2, and then a pair of brackets. For x, I put this expression. So it becomes minus 1 minus 3y. And then I have minus 4y is equal to what? 18. And now this is Math 1C problem, because there is only one variable left for you. So you just solve it as in any way that you learned before. So for example, let me multiply these two. Is 18. Minus 6y minus 4y is minus 10y. Minus 2 should move there. It becomes positive. It becomes 20. I divide by minus 10. Y is minus 2. Y is minus 2. Yes? And when I found minus 2, I am allowed to go to the first equation. I am allowed to go to the second equation. But which one is better? I will prefer this one myself. Yes? I take my y and put it here. Then it means that what happens for x? X becomes minus 1 minus 3 times y. Y is minus 2. So it becomes minus 1 plus 6, and that becomes 5. But you need to write the answer. So how many answers are there? How many? 1. So x is 5 and y is minus 2. So that's the answer to this problem. Yes? This is substitution. But addition method for these systems are good to know. Sometimes it is faster. As you see, it was much faster here. So now if I want to do the addition method, method number 2, addition. Okay, addition is not as simple as the previous one, because in the previous one, when I added, y was eliminated. But here, if I add, what happens? X is added to 2x, I will get 3x. 3y will be added to minus 4y, I will get minus y. So x and y will both survive. So adding immediately does not work. Okay? Is that clear? Yes or no? Because when the other system, do you remember, it was x minus x plus y equals to 3, I think. What was that? I forgot. And then this one, 7, something like this. Yes? In that case, when I start adding them up, this y and that y are gone. And then I am left with one variable. And that is good, because I want to get rid of one variable at a time to be able to solve it. You see, even substitution method helped me to do that. When I did this substitution, I got an equation with one variable. I got rid of the other variable here. So that's the whole point. We have to reduce the number of variables one at a time so that there is only one variable left and we can solve it, and then put it backwards and then solve the problem in total. So this was very simple because they were accidentally opposite. When I added them, it is gone. But here it is not working like that, because if I start immediately adding them, it becomes 3x. I didn't get rid of x. And it also becomes minus y. I didn't get rid of minus y either. Okay, so what should I do? Here you have to multiply one or both of the equations first by an appropriate coefficient. For example, let us first decide which variable you want to get rid of in the beginning. So let us say that I want to get rid of x first. You know that if you add these two, they will not cancel. So, but you will take the first equation and multiply it by minus 2. Okay? So let us see what happens. If I multiply the first equation by minus 2, what do I get? I get minus 2x minus 6y equals to what? 2. The second equation, I don't touch it. I just write 2x minus 4y equals to 18. But now, do you think addition is good here?
Yes.
Yes. Because if now I add, this one and that one are gone. And then this one becomes minus 10y, and this one becomes 20. And that is good because I have only one variable left and I can immediately find it by isolating it. Y becomes minus 2. Yes?
And which one do you think is easy?
I would say that for these kinds of problems that you have a lot in the book, addition method might be somehow more useful because you can see that. Of course, as this multiplication, you have to understand how to multiply to get rid of, yes, one of the variables. But we did it, and then, I don't know, that is up to you. I have written both on them, both ways on the board, so then you can judge it for yourself which one you prefer. Yes, but for these systems, addition method works, but addition method only works for these kinds of systems. If I want to solve that system, there is no addition method for that system. So that system only can be solved using the substitution method. Okay, so y is minus 2. And then what should I do for finding x? I have to put this back equation, this y, either here or there, or even in the very original equation. Because the original equation is simpler, I prefer to put in the original equation. So what happens? X plus 3y, which is minus 6, is equal to minus 1. Then I move 6 to the other side, so it becomes 5. And then I write the answer. So answer is x is 5, y is minus 2 again. So this one was addition method, that one was substitution method. Substitution method is also necessary. Later we will talk about those kinds of systems, and substitution method is only way for solving those systems. Any questions here? Yeah. So more or less the lesson is finished here, the lesson of systems, but I want you to practice. So I will write system, I want to solve it. And I prefer you to solve it in both ways, okay, for the system, for the first few systems. Okay, so now the example is this. Example, solve the following systems. Using both methods. But of course, in the exam, I will not ask you to solve them in both ways, and I don't tell you in which way. You can prefer, you can choose how you like to solve it, okay? So solve the following systems using both methods. So let me write one equation here for you. So the first system. The system is 5x plus 9y is equal to minus 2. And then I would write 2x plus 4y is minus 1. I want to wait for you, okay? I will write one more. If you're done, don't waste your time. Do the second one. They are extremely simple problems. I mean, this chapter is a very simple chapter. Of course, there are some hard problems as well, but I mean, the standard way is not hard at all. So I will write another system here for you. 2x minus 7y is equal to 22. And then 3x plus 5y is equal to 2. Yes? So in the addition method, as you see from the name, you're supposed to add. Okay? But adding sometimes directly works. For example, in the first system, it was so simple, and it was in a way that when I just start adding them up, then these two y's are cancelled, and then one x is left. But in the second equation, I don't remember, I think I erased that. So for example, in this equation, adding them immediately does not work, because this will be added to this, it becomes 7x, and this will be added to this, it becomes 13y. So these numbers are not fine-tuned like that first example. So then you have to fine-tune it yourself. For example, you need to decide about a number to multiply here, or sometimes in both of them, so that you make the coefficients opposite, and when you add them, one variable is gone.
When I use the addition method, can I do subtraction to subtract one?
Yes, yes. Addition and subtractions are the two sides of the same coin, because subtraction is adding with the opposite. Yeah, so this name is called addition, but of course, but let me not freeze you with the names. The goal is one thing: get rid of one variable. Okay, so that is the general strategy. When you want to solve a system, you have to get rid of one variable and make it an equation in one variable. The methods that they have designed for this is substitution and addition. It always works. But if you accidentally find a shortcut for getting rid of one variable, that's also working. Okay, so I will solve this in two ways. Method one, substitution. So for substitution, I have to make my mind about one of the equations. Which one you prefer?
X.
What?
X.
No, the equation first. First one or the second one? Second one seems better. Yes, the numbers are smaller. So first I choose the second equation. So 2x plus 4y equals to what? Minus 1. Now you have to decide about the variable you want to make isolated. Which variable you prefer? Yes, x is better. The coefficient is smaller. Okay, so I would write 2x is equal to minus 1 minus 4y, but I have to divide by 2 now. So x becomes minus 1 divided by 2, work with fractions, and then minus 4 divided by 2 is minus 2y. This is isolating one variable. And then you have to go back to your system. This is the equation you used. This is the equation that you haven't used. You have to substitute that expression for this x. So what I will do, I will write it here. So it becomes 5, open a pair of brackets, so this is 5, and instead of x, I put this expression, so it's minus 1 over 2 minus 2y, and then plus 9y is equal to minus 2. This is a Math 1C problem, because this has only one variable in it. Okay, so multiply 5 in, so it becomes minus 5 over 2. This becomes minus 10y plus 9y is equal to 2. Minus 2, sorry. Okay, so minus 10y plus y, 9y is minus y. I don't know. I prefer to get rid of fractions, so I prefer to multiply by a 2. So it becomes minus 5 minus 2y is minus 4. Then I isolate y by moving minus 5 to the other side. It becomes 1. Yes, because minus 5 moved there, it becomes positive 5, and that's 4. And then what is y? Y is minus 1 over. This is your y. You can put it back in any one of those equations, but this is preferable because you have already done the effort to find x, so why not use this one? X becomes equal to minus a half minus 2 times y. Y is minus a half. So it becomes minus a half. Minus 2 times minus a half is positive 1. But positive 1 minus a half is minus a half. Yes? So x is minus a half. So what is the answer finally? So the answer is x is minus a half, y is minus a half. Is that right? Did you also get the same answer? Or have I made a mistake somewhere? Is it mistake? This one works. Let me double check. If I put minus a half here, for example, let us say that I am suspicious about my solution. I want to check it out. How should I check it out? I have to put it back in this equation and this equation to see both of them work. Okay, for example, this one, if I put minus a half here, times 2 becomes minus 1. If I put minus a half here, times 1, so it is minus 2, so it is not working.
Yes.
Yes, so where did I make a mistake? Do you see that?
Yes.
Where is that? If you see that, you should tell me. Yeah.
Not there. It's in the X.
Here.
No.
So let me double check. So for x, this is minus 1. I move this to the other side. I divide it by 2. Everything seems fine. And then I put it in the first equation. And I multiply it here.
Baba,
Yes?
x becomes only one and a half.
Yes. Not minus.
Ah, this is okay. So that's the, thank you very much. Very minor mistake. Yes. Yes, because 1 plus minus a half. Yes, you are right. And of course, I detected that. Let us double check again here. Good. So if I put minus a half here, no, this x is 1 half. So it becomes 1. This becomes minus 2. Yo, that is correct. At least this works, but this is not enough. You have also to check this one. If I put 1 half here, 5 times 1 half, it becomes 2 comma 5. And 9 times minus a half, it becomes what? Minus 4 comma 5. But 2 comma 5 minus 4 comma 5 is minus 2. That's correct, yes. So that is the way. If you get suspicious that if your answer is correct or not, you have to take those numbers and put them back in both of them. If one of them works, it is not enough. You have to make sure the other one also works. So thank you very much for correcting. So that's correct now. But this is, if you write this, that's 100% correct. But I think addition method might be better here. So addition method, so let me write method 2. Addition. But for addition, you have to fine-tune it. This is not fine-tuned yet, yes? So what do you think it's a good idea to do? Concentrate on one of them. First of all, which one you want to get rid of? You have to decide about that.
The second.
Why? I mean, which variable you want to get rid of. Let us say I want to get rid of y first. I prefer to get rid of x first because the coefficients are smaller. But let us say that I want to get rid of y first. So how should I get rid of y? I have to make the coefficients opposite. This coefficient is 9. This coefficient is 4. So what I will do, I will, for example, multiply the first one by 4, but multiply the second one by minus 9. Yes, you might say why? Because I want to get rid of one variable. So let us see what happens. You will immediately understand. If I multiply this by 4, what happens? It becomes 20x plus 36y is minus 8. If I multiply this by minus 2, it becomes minus 18x. It becomes minus 36y. Is it good? Yes, because now they are opposite. And then minus 1, 9 times minus 1 is 9. And then I add them. So it becomes 2x. This is gone. It becomes 1. And as you see, it is much simpler. X is 1 half. Yes? But if x is 1 half, I need to find y. You can, in principle, put them in this one or that one, but it is not good because I have a simpler equation. I also prefer to choose the second one now. All of them will work. It doesn't matter where you put it. Choose the simpler one for yourself. I will choose this one. So I put here 2 times 1 half plus 4y is equal to minus 1. But 2 times 1 half is just simply 1 plus 4y is equal to minus 1. I move 1 to the other side. It becomes minus 2. So y becomes minus 2 over 4, which is minus a half. So you see that I would say that this method is faster here. Of course, you could have chosen to eliminate x first. For example, let me write with a different color here. So, for example, you might eliminate x first. If you insist to eliminate x first, what do you do? For example, you multiply the first one by 2. You multiply the second one by minus 5. So then what happens? If you multiply the first one by 2, it becomes 10x plus 18y equals to minus 4. The next one becomes minus 10x minus 20y equals to 5. Is it good now? Yes, because when I add, this time x is cancelled. No worries. This becomes minus 2y. This becomes 1. And y is minus a half again. And then when y is minus a half, put it back in one of the equations that you originally had. For example, here again. So I would write 2x. I multiply y by 4. It becomes minus 2 is equal to minus 1. So x becomes 1/2 again. So you see, here I decided to eliminate y by addition method. Here I decided to eliminate x by addition method. There I use the substitution method. So all of them will give rise to the same way. And I hope that you agree with me. Addition method for these kinds of systems at least is better a little bit because it can be done shorter. Okay, so that is the introduction to this lesson. Of course, there are many things coming and we will practice later. Any questions? Thank you very much.